All right, here we go. So I'm going to go through some examples with area between curves, hopefully quickly because these take a lot more time than some of the other problems we've been doing. So feel free to pause this video as you need to actually soak in the steps I'm going through. First, I want to talk about what the big idea is here for this lesson. So there's two situations for area between curves. I'm going to start with the one on the right here, where we're trying to find this space. So if you remember, an integral has been the area between the curve and the x-axis. Now we've got two different curves, we're finding the area in between them. And so we're going to calculate this still using an integral from our bounds. But we're going to use the upper function, so that's the one you can see in this diagram, is f of x, minus the lower function. And when you subtract those two, that's how you're finding the area in between them. If your function is written in terms of y, then you're finding them side to side instead of up and down. And so for this one here, our bounds are notated from c to d, just meaning that our bounds are in terms of y this time. And then we use the function on the left minus the function on the right. So we're just changing how we think about it a little bit. So let's go through a few examples here, starting with this one. And we are going to do the first couple without looking at them on a graph, because that's one of the skills on the AP test, is to be able to do this without graphing. And so to find the area between these curves, we first need to know where these curves intersect. So we're going to set them equal to each other. Then I want to get this equal to 0, so I'm going to move everything from the right side over to the left side. I'm going to add x squared and get 2x squared. I'm going to subtract 2x and get negative 6x. And when I subtract 3, the constants cancel out, so now my equation is equal to 0. I factor out a 2x from both sides, and I'm left with x minus 3. So I know that these equations intersect at x equals 0 and x equals 3. Those are going to be the bounds on my integral. The next thing I need to know is which one is the top function and which one is the bottom function. So I can figure this out just by testing a point in between this interval. So if I test the point 1, when I plug in 1 into this function, I get 1 minus 4 plus 3, which is equal to 0. Oops, and if I plug it into the the g of x function, so I'm finding g of 1, then I have negative 1 plus 2 plus 3, which is going to give me 4. So now I know that g of x is my top function. So I'm going to have negative x squared plus 2x plus 3 minus x squared minus 4x plus 3 dx. So now I want to simplify this integral before I do anything else. So I'm going to end up with negative 2x squared plus 6x dx. That's from combining those two there. And then I antiderive. So I have negative 2x to the third over 3 plus 3x squared. And this is being calculated from 0 to 3. So I plug in 3, and that's going to give me negative 18. And then I plug in 3 to 3x squared, and I get plus 27. When I plug in 0 to both of these, I just get 0. And so negative 18 plus 27 is equal to 9. So the area between those two curves is equal to 9 units. Let's look at example 2. You can see here that we're dealing with equations that are written in terms of y, so that means we're working side to side. We start with the same process by finding where the two of these intersect. So I'm going to set them equal to each other. I'm going to move everything to the right side so that my y squared term is positive. So I get y squared plus y minus 6 is equal to 0. This factors into y plus 3 and y minus 2. So my intersection points are at negative 3 and positive 2. So I know that those are the bounds on my integral. Remember, this is in terms of y, so this is up and down. And now I just need to figure out which one is the farther right. So I'm going to do that by testing a point. I'm going to test the point 0. When I plug in 0 here, I get 4. And when I plug in 0 to this one, I get negative 2. So I know that the first equation is my right side equation. So I have 4 minus y squared minus y minus 2 dy. When I combine this, I get negative y squared minus y plus 6 dy, and then I antiderive. So I'm going to have negative y cubed over 3 minus y squared over 2 plus 6y, evaluated at negative 3 and 2. That's going to give me negative 8 over 3 minus 2 plus 12. And then when I evaluate at negative 3, that's going to give me a positive 9 minus 9 over 2 minus 18. I would need common denominators and everything. I did all this work already so that I'd be prepared, but my final answer is 125 over 6 once I simplify all of that. Let's take a look at example 3. Now this one here is one that we would not do by hand. We want to look at the graph here. And once we look at the graph, we can establish kind of what we're looking at. So let's open up our graphing calculator. I'm going to graph the first function, which is negative x to the third plus 3. Whoops. Negative x to the third plus 3. And my second equation was just an x. So let me show that again so that you can see negative x to the third plus 3 and x. These values here, these are vertical lines at negative 1 and 1. Let me show you on a graph. That's because these two functions don't actually intersect. And so there's not an enclosed space between them. And so we have to have some kind of bounds on the side to close this space in. So you can see here that negative 1 is here. So imagine a vertical line there, and then positive 1 is here. So it's all that space below this blue line, but above the red line. And so this blue line here is my x cubed function. The red line is the linear function. So now I know that my integral goes from negative 1 to 1, that those are the bounds on my integral, that the upper function is negative x cubed plus 3, and the lower function is x. This one here I anti-derived, so I have negative x to the fourth over 4 plus 3x minus x squared over 2, and this is being evaluated from negative 1 to 1. When I plug in 1, I get negative 1/4 plus 3 minus 1/2. And when I plug in negative 1, I get negative 1/4 minus 3 minus 1/2. I distribute this negative, so this is going to become plus 1/4 plus 3 plus 1/2. And that means the 1/4 cancel out, the 1/2 cancel out, and all I have left is 3 plus 3, which is 6. The last example I want to go through with you is a trig example. Again, we're going to take a look at this on a graphing calculator, and we're going to have some discussions about what you need to know about the unit circle. So our functions here are sine of x and cosine of 2x on the interval from negative pi over 2 to 5 pi over 6. So to have a good idea of what this looks like, first I'm going to enter these functions. So we have sine of x, and then we have cosine of 2x. And so that I actually know what I'm looking at, I'm going to change my window. So I want my x min to be at negative pi over 2, since that's the left side of my interval. And I want my x max to be at, what was it at, 5 pi over 6. Negative pi over 2 to 5 pi over 6. And you can see that this calculator, and you probably know this by now, converts everything to decimals. And so we're going to have to do some work to know what values we're actually looking at. Okay, so this one here is a unique situation. This is an important situation for area between curves. If you notice, for the first part of this interval, the red function is on the top, the blue one is on the bottom. And then for the second half, the blue one is on the top and the red one is on the bottom. So that's an important thing to do. What we're going to do is split our integral at the point where they intersect. And when I split that, I create two integrals that I'm adding up. So we first need to know where they intersect. So I'm going to use the calc function on my calculator by going to second and calc. And I'm going to calculate the intersection point, which is option 5. Right now it's on the first curve, which is sine of x, and the little blinky thing is pretty close to the intersection point, so I'm going to hit enter. Then it moves to the red curve cosine of 2x. By this point, that blinky thing is where I want it, so I just hit enter again. And finally, down here you can see it's saying guess. So it's close to the intersection point, and then it tells you the intersection point is here at 0.5235988. Well, we need to know what value that is on the unit circle. So use some of your mathematical skills to help you with this, right? The options are pi over 6, pi over 4, and pi over 3. Well, pi over 6 is going to be the closest thing to 1/2, so that is a pretty good assumption. We could double check it on the calculator if you wanted by just evaluating pi over 6 and making sure it's the same decimal number. Okay, I'm telling you for the sake of time that pi over 6 is where they intersect. So what I'm doing here is I'm splitting my integral from negative pi over 2 to pi over 6. And remember, for the first part of this interval, it's the red function on top. So that's my cosine of 2x. So it's cosine of 2x minus sine of x. My other integral goes from pi over 6 to 5 pi over 6. And this is where they switch places, so sine of x is first. So we have to be setting up our integrals where the top function comes first and the bottom function comes second. Okay, from here, I'm going to do some integrating. This first one is a really basic u substitution, but you could go through the process of u substitution. It's going to give me 1/2 sine of 2x. And then when I anti-derive sine of x, I get plus cosine of x. This is going to be evaluated from negative pi over 2 to pi over 6. For this part here, sine of x is going to become negative cosine of x, and then negative cosine of 2x, when you anti-derive it, you get negative 1/2 sine of 2x. And this one is going to be evaluated from pi over 6 to 5 pi over 6. So this is where, on an AP test, there is a possibility that a question like this would be a non-calculator question. You have to know your unit circle. Okay, you've got to know what those points are. So when I plug in pi over 6 here, I get 1/2 sine of pi over 3, because I'm multiplying that by 2, plus cosine of pi over 6. And then that's being subtracted from this evaluated at negative pi over 2. So 1/2 sine of negative pi plus cosine of negative pi over 2. Well, we should know on our unit circle that sine of negative pi is 0, so that goes to 0, and that cosine of negative pi over 2 is also 0, so that goes to 0. So all we care about here is 1/2 sine of pi over 3 and cosine of pi over 6. Well, sine of pi over 3 is equal to the square root of 3 over 2. Cosine of pi over 6 is also equal to the square root of 3 over 2. I do the same thing over here with 5 pi over 6 and pi over 6. So negative cosine of 5 pi over 6 minus 1/2 sine of 5 pi over 3. And then I subtract this and I'm evaluating my function at pi over 6, which I actually just did right over here on the left. So I have negative, oh no, I'm sorry, different function. Don't do that. Pi over 6 minus 1/2 sine of pi over 3. Okay, cosine of 5 pi over 6 is in quadrant 2, so that means that cosine is negative over there. So I have a negative times a negative, which is a positive square root of 3 over 2. Sine of 5 pi over 3 is in quadrant 4, so that means that sine is a negative down there. So I have negative 1/2 times negative square root of 3 over 2. And then this is being subtracted from negative cosine of pi over 6, which is negative square root of 3 over 2. And then we have negative 1/2 times sine of pi over 3, which is the square root of 3 over 2. From here, remember that we're combining all of this together. So this part right here plus all of this right here. When you add all of this together, you can pause if you'd like and take some time to do this on your own. But your final answer should be 9 square root of 3 over 4. I did double check this in a calculator, and I want to show you how I did that real quick so that we have a good understanding of those calculator functions. So I'm using integral, which is in the math menu. It's option 9. Remember the lower bound on the first integral was from negative pi over 2, and then the first integral went to pi over 6. That was where we had cosine of 2x on the top. So cosine of 2x makes you close those parentheses and then subtract sine of x and close those parentheses, and you've got to put that term of or variable of integration in there. Then we add it to the other integral, so back to math option 9. We go to pi over 6, and the upper function here is 5 pi over 6. And this time sine of x is on the top, so it's sine of x, close those parentheses, minus cosine of 2x. Put that variable of integration in there and press enter, And you'll see that that